Welcome to my YouTube channel. Watch, like, share and comment. Yes, so in our today's lesson, we shall be looking at the periodic table, and more specifically, we shall be trying to understand the structure of the atom. Remember to subscribe to the channel so that you don't miss other outstanding lessons on the same topic, understanding the periodic table. So in our today's lesson that I've mentioned, we have the lesson objectives, and by the end of the lesson, you should be able to meet the following objectives. So by the end of the lesson, you should be able to define an atom, the protons, the nucleons, and the electrons. You can note down these objectives so that you can always refer by the end of the lesson whether you're able to master the following concepts. Number 2 is describe the structure of the atom. Then objective number 3, by the end of the lesson, you should be able to differentiate between the mass number and the atomic number. And finally, distribute electrons in the energy levels. So we begin by the structure of the atom, and like you can see here, we have an example of this particular atom, and an atom is usually made up of two main parts. The first part is what we have here at the center, called the nucleus, and then we have this outer shell or outer region. All of this is called the energy level. So the number of energy levels depend on the size of the atom. We have atoms, we have atoms like hydrogen that have only one energy level. We have others like lithium that have 2 energy levels, and we also have others like magnesium with 3 energy levels, and a maximum of 4 electrons for the first 20 elements. We have potassium and calcium. So basically that is what we call the energy levels and the nucleus in the structure of an atom. So the region denoted as the nucleus is usually occupied by particles, and these particles are number 1 called we have neutrons, and then we have also protons. So the neutrons and the protons reside within the nucleus of an atom, and in one name they are referred to as the nucleons. And then we have the electrons, which are usually distributed within the energy levels. So the electrons are not found in the nucleus. They are usually in or within the energy levels. The number of electrons is always equal to the number of protons, and that tells you that if you know the atomic number, you can be able to get the number of protons, because the atomic number, which is equivalent to the number of protons, is also equal to the number of the protons in a given element. And like you can see here, let me rub this so that you're able to see. The neutrons, like the name goes, are usually neutral. So they don't have any particular charge. So they are electrically neutral. Then we also have now the protons, and like they appear in the drawing here, the protons usually have a positive charge, and they are therefore electrically positive. We also have the electrons within the energy levels. Again, they are negatively charged, and therefore we can say that an atom is made up of 2 parts, that is the energy levels and the nucleus, and the nucleus is the innermost part. And then now that region, which is called the nucleus, is occupied by the protons and the neutrons, and then we also have now the outer shell, which is occupied by the electrons. That is all what we can say about the structure of an atom. And let us now look at the atomic number and the atomic mass, or the mass number. So like we mentioned in our previous slide, we said that an element like lithium, for example, this is lithium. Lithium has an atomic number of 3. So that tells you that it has 3 protons. And like I've just mentioned, the number of protons is always equal to the number of electrons. So that means that it will have 3 electrons. We go back now to our slide, and from that we can be able now to see this, that the atomic number for lithium is 3. What does that tell you? This number of protons, or the atomic number, will give us the number of protons. And also the atomic number is always equal to the number of electrons, because the number of protons for a given atom is always equal to the number of electrons. And from that, therefore, we can be able to conclude that lithium has 3 protons. It has got 3 protons, and you can see that. And it also has 3 electrons. But note that the number of neutrons is different, because it has a total of 4 neutrons. So therefore, when we take the number of neutrons here, the number of neutrons, then we add it to the number of the protons, what we get is the mass number. Note that neutrons plus protons, we get the mass number. What does that tell you? That the mass number of lithium is therefore the number of neutrons, and what in our case here, the number of neutrons are 4 plus 3 electrons, and that now gives us 7. It gives us now 7 as the mass number of lithium. So to define, atomic number is the number of protons in the nucleus of an atom, while the mass number is the sum of the protons and the neutrons in the nucleus of an atom. We look at something different, and that is on energy levels now. So the energy levels, like I've just mentioned, we have different elements or different atoms having different number of electrons. What does that mean? For example, an atom like hydrogen here, hydrogen has 1 proton. That means that it also has 1 electron. So if we were to draw the atomic structure of hydrogen, we would just come here and place our electron in that energy level, the first energy level. And let me draw it better. Try to draw it better. We would have now, yes, the first, just 1 electron there, and that now shows hydrogen. We would replace now here and write hydrogen with only 1 electron. Now if we get to lithium, lithium has a sum of 3 protons. So what does that tell you? The number of protons is always equal to the number of protons is also equal to the number of electrons, and therefore lithium also has a sum of 3. Okay, let me just write it better. Lithium in this case will have 3 electrons. How do we draw 3 electrons in lithium? We will have the first electron here and the second electron here. All these electrons are in the first energy level. Why? Because the first energy level for any atom can only accommodate a maximum of 2 electrons. And this is what we call the duplet. The duplet state. You didn't get that? That the first energy level can only accommodate a maximum of 2 electrons. So for lithium, we have the first 2 electrons in the first energy level, and then now the second energy level will get the third electron. So we have how many electrons? We have now 1 electron, we have 2 electrons, and we have 3 electrons, and that is just for lithium with 3 electrons. The second energy level, the third energy level, and the fourth energy level can accommodate a maximum of only 8 electrons. And that state, we call it the octet. The octet state. So the first energy level, only 2 electrons, like you can see here. And we call that on duplet state. And then we have 8 electrons with what we are calling the octet state. So that is for lithium. We can look at another example. Another example is, we can use another example of magnesium atom. So magnesium atom, the atomic number of magnesium, this is where we have magnesium. Magnesium has an atomic number of 12. And what is 12? Magnesium. That is the number of protons. That tells us that the number of electrons is also 12 because the number of electrons is always equal to the number of protons for an atom. So we have 12 electrons. So we need to ask ourselves, how will these electrons be distributed in the atom of magnesium? And this is how the electrons will be distributed. We will maybe call this one now, let me change the color. We will call this one magnesium, and then that is Mg for Mg, and then we have the first electron, and then we have the second electron, which are within the first energy level. Remember, we have said that the first energy level can only accommodate a maximum of 2 electrons. So the third electron will get to the second energy level like that. And then, like we have said, the second energy level can accommodate a maximum of how many electrons? 8 electrons. So if the first 2 electrons are in the first energy level, we'll have the 4th, 5, 6, 7, 8, 9, 10. So those are 10 electrons. So if you number this one now, you can know that we have 1 electron, we have 1 electron, we have 2 electrons, we have 3 electrons, 4, 5, 6, 7, 8, 9, 10. But then magnesium has a maximum of how many electrons? 12 electrons. So we have 2 more electrons. And because these 2 electrons cannot fit in the second energy level, now we move on to the third energy level, and then we will have the first electron there and the other one here. So in this case, now we have the structure of magnesium atom having 12 electrons distributed among the energy levels. In that case, we can say that magnesium has a maximum of 3 energy levels. When we get there, we can try still another example. And that example is, what do you think is the next example? We cannot live without oxygen, and therefore let's try to draw the structure of oxygen. From the periodic table, remember again that oxygen has an atomic number of 8. So if oxygen has an atomic number of 8, that tells you that it has a total of 8 protons. So if oxygen has 8 protons, it also has 8 electrons, because the number of protons is always equal to the number of electrons. So we will try to distribute these electrons in the period in the energy levels like we have done for magnesium, and that is oxygen. So the first energy level again will only accommodate a maximum of 2 electrons. Now we have a total of 8 electrons. If 2 electrons are in the first energy level, we have 6 more electrons to distribute, and those 6 electrons will all fit in the outermost, in the second energy level, like that. So we have a total of, we have now 1, 2, 3, 4, 5, 6, 7, 8 electrons. All those 8 electrons are the electrons for oxygen, and therefore, because like you can see, we have the second energy level now is not complete. Remember, we said that the second energy level can hold a maximum of 8 electrons, and it has only 6 electrons. That tells us that oxygen has a maximum, as oxygen has 2 energy levels. Call it energy levels. Yes, this is not how we write energy levels. Yes, oxygen has only 2 energy levels. Now, you need to practice how to write energy levels. For example, for chlorine, you can pause the video and try to draw the atomic structure of chlorine. I hope you have your answer now. Let's try now to draw the structure of chlorine together, and you can mark for yourself whether you got it right or you got it otherwise. I hope you are a good student and you got the correct answer. So from our periodic table again, chlorine, like you can see here, is atomic number 17. So if it is atomic number 17, that tells us that the number of electrons for chlorine, the protons are 17, which are equal to the number of electrons, which now will also be equal to 17 electrons. So we will need to distribute these 17 electrons in the atom, and in this case it is within the energy levels. As usual, the first energy level will carry a maximum of 2 electrons. Then the second energy level will have a maximum of 8 electrons, because we said that it has an octet. It can only accommodate 8 electrons, and that is it. Those are 8 electrons, and therefore we are left with how many? So 8 plus 2, that is 10. So 17 minus 10 we have 7. So we have 7 more electrons, and those electrons will of course now get to our last energy level. So we will have the first electron, the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one. So the total of these electrons is 17, and basically that is the structure of chlorine atom. Thank you for watching this lesson. I wish to remind you to subscribe to this channel and watch the next episodes so that you understand more about the structure of an atom and even the periodic table in depth. Share the lesson with your friends so that together we build an ocean of chemistry. Thank you.